Imagine stepping into an elevator. This is no ordinary elevator. It whisks you upwards past the clouds, past even the International Space Station. Your destination? Space itself. This is the dream of a space elevator, a revolutionary way to travel beyond Earth. But how do we build such a structure, one that stretches tens of thousands of miles into space? The answer lies in finding materials strong enough to withstand the immense forces involved. Think of a heavy book hanging from a string. If the string isn't strong enough, it snaps. The same goes for a space elevator. We need incredibly strong materials to hold it together. This is where things get really exciting. Scientists and engineers are hard at work developing materials that could make the space elevator a reality. These materials are not just strong, they're super strong. They have names like carbon nanotubes and graphene, and they sound like they're straight out of a science fiction movie. Let's talk about strength. Not the kind you need to lift weights, but tensile strength. Imagine pulling on a strand of spaghetti until it breaks. That's tensile strength. How much pulling force something can withstand before it breaks. Now, imagine that spaghetti strand, but 100 times thinner than a human hair and incredibly strong. That's a carbon nanotube. These tiny tubes of carbon atoms are some of the strongest materials known to science. They're like miniature super strong cables, perfect for building our space elevator. Carbon nanotubes get their strength from the way their atoms are arranged. Imagine carbon atoms holding hands in a very specific pattern, forming a super strong bond. This unique structure makes them ideal for supporting the weight of our space elevator. But carbon nanotubes aren't the only contenders in the race for space elevator materials. If carbon nanotubes are like super strong cables, then graphene is like super strong fabric. Imagine a sheet of carbon atoms, just one atom thick, arranged in a honeycomb pattern. That's graphene, and it's even stronger than carbon nanotubes. Graphene has amazing properties. It's not only strong but also incredibly light and conducts electricity very well. It's like the superhero of materials, with the potential to revolutionize not just space travel, but also electronics, medicine, and many other fields. But the search for the perfect space elevator material doesn't stop there. Scientists are also exploring other exciting candidates, like hexagonal boron nitride and diamond nanothreads. These materials are like cousins of carbon nanotubes and graphene, each with its own unique set of properties. Hexagonal boron nitride is known for its heat resistance, while diamond nanothreads are incredibly stiff. These properties make them valuable not only for space elevators but also for other demanding applications, such as building stronger and lighter aircraft or developing new types of protective gear. Section 4. The price of progress, challenges, and costs. While these materials sound amazing, there's a catch. Producing them in large quantities and at a reasonable cost is a huge challenge. Imagine trying to build a skyscraper with millions of tiny microscopic bricks. That's the scale of the challenge we face with these nanomaterials. Creating carbon nanotubes, graphene, and their counterparts often requires specialized equipment and controlled environments. It's like baking a very complex cake. You need the right ingredients, the right oven, and a lot of patience. The cost of producing these materials is another hurdle. Imagine building a bridge out of gold. It would be beautiful but incredibly expensive. Similarly, using large quantities of these advanced materials for a space elevator comes with a hefty price tag. But scientists and engineers are constantly working on new methods to make the production of these materials more efficient and affordable, bringing us closer to the dream of a space elevator. Section 5. A giant leap for humanity. Benefits of a space elevator. So why go through all this trouble? Why spend so much time, effort, and money on developing these materials and building a space elevator? The answer is simple. The potential benefits are enormous. Imagine a future where traveling to space is as easy as taking an elevator ride. No more expensive and dangerous rocket launches. A space elevator could transport people, satellites, and even resources to and from space at a fraction of the cost. This could revolutionize space exploration, making it possible to build space stations, lunar bases, and even launch missions to Mars more easily and affordably. It could also open up new possibilities for space tourism, making the wonders of space accessible to more people. Section 6. Building the future, one material at a time. The space elevator is an ambitious dream, but it's not an impossible one. With continued research and development, these incredible materials, carbon nanotubes, graphene, and their counterparts, could hold the key to unlocking a new era of space exploration. The challenges are real, but the potential rewards are even greater. Imagine a future where we can travel to space not as explorers on a daring mission, but as commuters on a daily commute. The journey to the stars begins with a single step, and in this case, that step involves developing the materials that will make this incredible journey possible. So, the next time you see a strand of spaghetti, think about the incredible strength hidden within its structure. And who knows, maybe one day, that same principle will take us all the way to the stars.